Click the bell icon to get latest videos from Ekeeda.
Hello friends, and today we are going to study a numerical number 4 which is based on convolution of signals using inverse Z transform. Problem number 4. So we'll see the question and then we'll think about its solution. Problem number 4. Find inverse Z transform of function x of z, and it is z square upon z minus 1 by 4 raised to 2, or you can say z minus 1 by 4 square. And the ROC is also given mod z is greater than 1 by 4, that is it's a causal sequence, and we have to find out inverse Z transform but using convolution theorem. Now remember one thing, if you have gone through the last video then you will get the idea. We are going to split this function into two parts. Now here in numerator and denominator we have the square, so I can split this function like z upon z minus 1 by 4, and the second part is again z upon z minus 1 by 4, so that after multiplying you will get the same function, but after separating you can replace it by x1 of z and x2 of z, and then go for inverse Z transform of both these functions, and then after that we will use a convolution of signals or discrete time signal to get inverse Z transform of x of z, that is x of n. So my x of z is z square upon z minus 1 by 4 the whole square. So I'll split both these functions into two parts. How? Z upon z minus 1 by 4 and z upon z minus 1 by 4. So these are my two functions. If I multiply both these functions, then of course you will get this answer. Now I'll consider this is nothing but my x1 of z and this 2 is nothing but my x2 of z. So I can write this one as x1 of z and x2 of z. So this is my x1 of z and x2 of z. So I can write x1 of z multiplied with x2 of z. Now what is x1 of z? Basically z upon z minus 1 by 4. Now if you go for inverse Z transform of this, then I can write this x1 of z by x1 of n, and z upon z minus 4, this is a time scaling property and which is applied on u of n. So according to it we can say that my a value is 1 by 4, so I can write 1 by 4 raised to n into u of n is the inverse Z transform of z upon z minus 1 by 4. So similarly x2 of z is also having the same function, so I can say that my x2 of n is also having the same result. That is, look at this. Let's say this is my equation number 1. So if we apply inverse Z transform on this function, then two functions multiply with each other, then it is nothing but the inverse Z transform of convolution of two signals. So let's apply inverse Z transform on equation number 1. So my x of n becomes x1 of n convolved with x2 of n. But if we use a definition of convolution, then it is nothing but summation value, a summation where k value varies from minus infinity to infinity. x1 of n is represented by x1 of k and x2 of n is represented by x2 of n minus k, or you can say minus k plus n. Now look at here, my x1 of n is basically, I can say that x1 of n and x2 of n both are same, so I'm going to write it in one line, 1 by 4 raised to n u of n. So if my x1 of n is 1 by 4 raised to n u of n, if I replace this n by k, so my x1 of n equation becomes or can be written as x1 of k, this all n replaced by one by 4 raised to k u of k. And similarly, my x2 of n is also this, but if this n is replaced by n minus k, so all this n is also replaced by n minus k. So my x2 of n minus k can be written as 1 by 4 raised to this n is replaced by n minus k. Similarly, my u of n is also replaced by u of n minus k. Now I'm going to substitute both this value in my equation. So my x1 of n is Now I'll split this order because 1 by 4 raised to n is the constant term. So I can take 1 by 4 raised to n outside this summation bracket. Now look at here. I have splitted the order of n minus k into two parts. So 1 by 4 raised to n and 1 by 4 raised to k. Now I will take, this is a minus k. Now I will take 1 by 4 raised to n outside. So look at it, I have taken 1 by 4 raised to n outside, the summation value, and we have 1 by 4 raised to k and 1 by 4 raised to minus k. If the bases are same, then powers can be added. But after adding these powers, k minus k becomes 0, and anything raised to 0 is always 1. So 1 by 4 will be replaced by both the 1 by 4 raised to k replaced by 1. So in summation, you will get only this u of n minus k and u of k only. Now I will draw both this graph. So first of all, I will draw u of k, and then later on I will add some advanced value, that is plus n, and then I will take the mirror image, and after that, after plotting both this graph, we'll multiply both of them so that you will get the summation k value. To solve this next product, we require the summation value. Now I will draw the graph of u of k as well as u of minus k plus n. Now u of k, we know that unit step always started from 0 and having amplitude 1 till infinity. So I can write, so I can draw this graph from 0 and up to infinity is having amplitude 1. This graph is advanced, or you can say shifted to left hand side by value n. So I'll draw this graph from here. Graph is shifted to right hand side means what? This origin is now shifted to left hand side means what? This origin value will shifted to left hand side by value n. So this graph will be continued till infinity. Now if we go for mirror image of it, then I can draw this graph like from minus infinity, it is having one amplitude, and that is my 1, and this amplitude, or you can say this discrete sample graph, is continuous till n is on right hand side. Or you can say, if I multiply minus sign with all the instants of time, then this was the highest limit of infinity. Now after multiplying minus n with infinity, it will become this lowest value, that is a starting point of this graph, and this n is multiplied by minus sign. So already it is on left hand side, so it will carry some negative values, but after multiplying with the minus sign, it will be shifted on right hand side. So this will be the terminating point of this graph. Now what do you mean by this? U of k is multiplied by u of minus k plus n. So this is my u of k and this is my u of minus k plus n. Now look at it. If we multiply both this graph, then look at here on the left hand side of this graph, it is having amplitude 0. So if we multiply a left hand side with u of minus k minus n, of course you will get answer 0, which means after multiplying these two graphs, the summation value, that is a lowest value of k, will start it from 0. Because on left hand side this u of k is having amplitude 0, this u of minus k plus n is having some amplitudes or having some graph, but after multiplying both this graph, both the left hand side of graph will be replaced by 0, because here we have amplitude 0, which means our graph will of course start from k value equal to 0. Now where this product will terminate, so look at here, up to n both this graph is having amplitude 1, but after n this is having amplitude 0, which means after multiplying 0 with this rest of the part, whole u of k part which is after or which comes after n will be replaced by 0. Now here the u of k is varied till infinity, but u of minus k plus n is varied up to n. Now it is having amplitude 0 after n. Now if I multiply both this graph, then what will happen? The sample value which is comes after n having amplitude 1, but here the sample value comes after n having amplitude 0. So after multiplying both this graph, what is the outcome? Your product will terminate at n, and after n it is not having any sample value. So my k value will vary up to sample value n. So I will substitute both this value in my formula. Now look at here. What we will get? 1 by 4 is to n summation value, k value varies from 0 to n, and after multiplying, or you can say in between 0 to n, we are having amplitude only 1. Now we can replace this 1 by k raised to 0, because I'm going to use one formula over there. K equals to 0 to n, and here we have a k to the power 0. If I substitute any value over here, then anything raised to 0 is always 1, and it is nothing but, if I open this summation value, then I'm going to substitute all the k values over here till n, and what you will get, our answer is always 1 plus 1 plus 1 plus 1 plus, and it is so on. So I can write this whole one as n plus 1. That is, if I substitute here the 0, then this n is replaced by 0. So 0 plus 1 is always 1. So you will get the same result. Now I'm going to substitute this n plus 1 over here, or you can say this whole summation is replaced by n plus 1. But basically, so I'm going to substitute this whole summation value n k to the power 0 by n plus 1. So what you will get? And now this n plus 1, we can say that this n plus 1 is multiplied by 1. If it is multiplied by 1, which is nothing but this is the value of u of n, because u of n is having amplitude 1 till infinity. So we can multiply it by u of n, and this is nothing but my result, or inverse Z transform of x of z. So this is our result. Thank you for watching this video. Stay tuned to Ekeeda and subscribe to Ekeeda for further more videos. Thank you so much.